So guys, if you're not done, better stop writing. So correlation and regression, guys, the first thing that we have learned in this chapter is about bivariate frequency distribution or multivariate frequency distribution. In the previous chapters, measures of central tendency, measures of dispersion, we have learned about frequency distribution, guys, of only one variable, correct, Yuvraj? So that's called as a univariate frequency distribution. If you have more than one variable, it is called as multivariate frequency distribution. Usme beta, if you have only two variables, that will be called as a bivariate frequency distribution. Now you need bivariate frequency distribution, guys, if you were to establish a relation between two variables, guys, to know whether the variables are positively related or negatively related, and to estimate the value of one variable for a given value of the other variable. This is where you will need data, guys, on the two variables collectively. So this bivariate frequency distribution, guys, is also known as your joint frequency distribution. Isme, guys, I said you should know what is a marginal distribution, what is a conditional distribution. There are how many number of frequency cells. So if you have 10 class intervals of the first variable and 10 class intervals of the second variable, the total number of frequency cells will be 10 into 10, 100. We have learned that as P into Q or M into N. M class intervals of the first variable, N class intervals of the second variable. A conditional distribution, beta, is distribution of one variable for a given condition of the other variable. So you are constructing frequency distribution of Y variable, but only of those X values as such, guys, which are in the range of 0 to 10. So that will become a conditional distribution. ऐसे हर एक class interval beta can become one condition. So if you have 10 class intervals of the first variable, 10 class intervals of the second variable, the total number of conditional distributions will become 20, 10 plus 10. Marginal distribution, guys, is distribution of only one variable. So if there are two variables, you will have only two marginal distributions. Now these frequency cells, the values that are taken by frequency cells, guys, can never be negative. You can either have a zero frequency value or you can have some positive value. Variable ka value can always be negative, guys. Zaruri nahi hai that it should only be zero or positive. The number of times that variable occurs can never be negative. It will either be zero or it will be some positive value. So if they ask you about beta, what can be the value of the random variable, the answer will be it can either be negative, positive or zero. But if they ask you about what will be the value for the frequency of a random variable, the answer beta will always be zero or a positive value. Are we clear? After this, guys, this chapter is segregated into two parts. The first part is correlation. Correlation is used to know whether the two variables are related, and if yes, what is the extent of relation, also known as the strength of relationship. When you say two variables are related, guys, or they are associated, they can either be related positively, guys, or they can be related negatively. When I say positive relation, they move in the same direction. Always never. They move in the same direction. If one variable is increasing, the other variable is also supposed to increase. If one variable is decreasing, the other variable will also decrease. If the relationship is negative, guys, that means the variables will be moving in the opposite direction. Increase in one variable will result in a decrease in the other variable. If there is absolutely no relation between the variables, guys, then they're known as disassociated as such, guys, or independent variables. This is where beta, we term it as zero correlation. They've given the example of shoe size, beta, and intelligence. Positive correlation ke liye, what were the examples given? It can be the amount of investment and profit. It can be the amount of rainfall and the agricultural yield, guys. For negative correlation, number of claims as such, guys, and the profits of an insurance company, demand and price. They also share a negative relation. Are we clear about this? Now, to measure correlation, guys, whether it is positive or negative, there are four methods. The first one, beta, is scatter diagram. All you have to do in scatter diagram, beta, is the entire bivariate data that you have collected will be plotted on a graph. You will plot xi values, yi values on a graph. Depending on the pattern of the plotted points, guys, you're going to determine the correlation. If the pattern of the plotted points as such, guys, move from lower left to upper right, that means it is positive correlation. If it is moving from upper left to lower right, it means it is negative correlation. If they are scattered all over the graph, which means there is no pattern, it would mean that there is zero correlation. If all the plotted points, guys, lie on a straight line, that means R will either be +1 or -1. If it has a positive slope, then it is +1. Negative slope, it is -1. Just because R is +1, that does not mean that the percentage change in variables should be same. It only means whatever is the slope, जो भी delta y by delta x है, it is constant. If delta y by delta x is 3, it will always remain at 3. So as long as the change is constant, guys, you will get r as +1 or -1. Scatter diagram का advantage beta is that it can be used for both linear as well as curvilinear relationship. The drawback of scatter diagram is that you will not be able to compute the strength of relation. You will only know whether the variables are positively or negatively related. Of course, you can determine the value of r beta when it is +1, -1 or 0, but except that, बाकी कोई भी value of r cannot be computed using scatter diagram. Are we clear about this? The next method that we did beta was Carl Pearson's product moment correlation coefficient. This is mathematically computed based on all the variables. For this, the first thing that we have understood beta was covariance. I said standard deviation, guys, measures the deviation of one variable. Variance is also measuring deviation of one variable. Covariance measures the combined deviation of two variables. So when one person yawns, if the other person is also yawning, guys, it means that there's positive correlation. Yes or no? So guys, covariance measures the combined deviation between two variables. So covariance का formula beta is summation xi minus x bar into yi minus y bar divided by n. Or you will write summation xi yi by n minus x bar y bar. If this total summation is positive, that means the variables are positively related. If the total summation is negative, that means the variables are negatively related. The drawback of covariance is that it's an absolute measure. Because it is an absolute measure, you will not use this for the purpose of comparison. This is where R comes into picture. R is correlation coefficient, a relative measure for covariance. You are comparing covariance with the product of individual standard deviation. So that is why we write R is equal to covariance between x and y divided by product of standard deviations. Simplified formula of that beta is there. Okay? But advantage of R beta is that it can be used for the purpose of comparison. That is why it is a relative measure, guys, unit free value. Now based on this formula, the value of R is always going to lie beta between +1 and -1. The value cannot be more than +1, it cannot be less than -1, because individual deviations as such, guys, have to be and have to more than the combined deviations. There's absolutely no way that the individual deviations will be less than the combined deviations. That is why the value of R beta will always lie between +1 and -1. The properties that we have learned better here in relation to R under Carl Pearson's method is that R is a relative measure, guys, and then the value of R will always lie between -1 and +1. The most important property being change of origin and change of scale. R being a relative measure, guys, which is a comparison of two values, it will not be affected by change of origin or change of scale. However, the sign may change. Positive correlation may become negative, negative correlation may become positive. Now this is possible only when you multiply one set of values with positive value and the other set of values with. So I told you beta, all you have to do is just compare the coefficients. अगर दोनों coefficients positive है, sign will remain same. दोनों coefficients negative है, even then the sign will remain same. एक positive है, एक negative है, the sign is going to change. Are we clear about this? Then guys, Carl Pearson's का सबसे बड़ा drawback is that it cannot be applied as such beta to curvilinear relationship. If applied to curvilinear relationship, you will get the value of R as 0. That does not mean there is no relation. Last time when we are doing review of correlation coefficient, guys, we have learned that if R is 0, we cannot conclude that the variables are independent. There's a possibility beta that there is an curvilinear relationship between the variables. However, if the variables are independent, R will definitely be 0. This was all about Carl Pearson's product moment correlation coefficient. After this, we moved on to Spearman's rank correlation coefficient. Spearman's rank correlation coefficient related, first thing that you should remember is that it is used for determining correlation between two attributes. And then it is also used to find out the level of agreement or disagreement as such, guys, between the ranking given by two different individuals. In order to arrive at Spearman's rank correlation coefficient, you will have to first rank the observations if they're not already ranked. Ranking will be obviously based on the values of the underlying variable. Then we have to compute DI, which is difference in ranking. Once we compute DI beta, the formula for computing R is equal to 1 minus 6 times of summation DI square divided by n into n square minus 1. If at all there's a tie in observations, guys, the ranks that will be allocated will be an average of the ranks that would have been allocated had it been different values. जैसे second, third, fourth में 5 50 50 50 guys. The rank to be allocated will be 2 plus 3 plus 4 divided by 3. Rank 3 will be allocated to all the observations and the next rank will directly be 5. You will not allocate 4 to anything. Are we clear? Likewise, 5th and 6th place mein beta, if I have say 45 and 45, the rank to be allocated will be 5 plus 6 by 2, 5.5. That is first change. The second change is in the formula. Apart from writing 1 minus 6 times of summation di square, you will also have to add summation tj cube minus tj divided by 12. Here t beta is the number of observations in which there is a tie. If there's a tie in 3 observations once, then tie in 2 observations, and then another tie in 2 observations, it will become 3 cube minus 3 by 12, 2 cube minus 2 by 12, 2 cube minus 2. Every time there's a tie, tj cube minus tj by 12 will come. Are we clear, guys? Even based on this method, the value of r beta will always lie between minus 1 and plus 1 only. Koi bhi method le lo beta, the value of r will always be between minus 1 and plus 1, both the limits included. The last one that we did, guys, was concurrent deviations. Concurrent deviations as such, guys, does not take the magnitude of observations into consideration. That is why beta we say that it is a casual method of finding out correlation, just to get a first-hand impression of what is the likely relation between the two variables. To compute correlation between two variables under this method, you will have to check whether the variables are moving in the same direction or opposite direction. Does not matter, guys, if one variable is increasing by 1 crore percentage and the other variable is increasing only by 0.01%. Even if that happens, guys, as per this method, they are moving in the same direction. That's it. So in case the variables move in the same direction, it is called as a concurrent deviation. So if I have 10 set of observations, agar n 10 hai, the total number of deviations that you will be able to measure will only be 9. Out of those 9 also, you will have to check how many are concurrent deviations, which will be measured by C. The formula will be root over 2c minus m divided by m. If 2c minus m is negative, overall r value will be negative. If 2c minus m is positive, r value will be positive. Are we clear about this, guys? If they always move in the same direction, r will be plus 1. If they never move in the same direction as such beta, r will automatically be minus 1. Now, a comparison of all the methods, guys. Most appropriate method will be Carl Pearson's product. Lekin uska drawback hai beta. What is the drawback of that? Drawback of that as such beta is that it cannot be used for curvilinear relationship, guys. Advantage of scatter diagram is that it can be used for curvilinear as well as linear relationship. In the end, we have also learned about coefficient of determination and non-determination. This is where I spoke about what is systematic risk and unsystematic risk. I said systematic risk as such, guys, is on account of macroeconomic factors that will affect the performance of all the companies as such, guys. Unsystematic risk is on account of company specific factors. Overall paper ही अगर tough आया समझो systematic risk. अपन अच्छा नहीं पढ़ के गए, unsystematic risk. Simple भाषा में. Are we clear? Coefficient of determination, guys, measures the proportion of systematic risk in the overall risk. But you should remember it as explained variance and total variance. So explained variance divided by total variance will be coefficient of determination. To compute that coefficient of determination, you should square R value. So if R is 0.8, coefficient of determination will be 0.8 whole square, which is 0.64, which means 64% of your overall variance is on account of explained factors. The remaining 36% is on account of unexplained factors. Are we clear about this? ये जो standard error and all दिख रहा है बेटा, I'll talk about this later as such, guys. Not relevant now. We'll see in sampling as such better, and then once I do normal distribution, अभी के लिए it's not relevant. And after this, guys, we finally moved on to regression. Regression is required because correlation coefficient will only tell us whether the variables are positively related or negatively related. You will not be able to compute the value of one variable for a given value of the other variable. To do that as such, guys, you need to establish a mathematical relationship, guys, between the variables. Last bench better address. You need to establish a mathematical relationship between the variables. So regression analysis helps us in establishing a mathematical relationship and also estimating the value of one variable for a given value of the other variable. Now, what is important to understand better is, unlike correlation where whether it is x to y or y to x, relation does not change, regression coefficient mein beta equation can change. For all of this, guys, I told you that you will have to understand what is minimization of vertical distances and minimization of horizontal distances. Yaad aa raha hai beta? So I said if y is dependent on x beta, we call x as the independent variable, y as the dependent variable. This is where we will form an equation in the form of y is equal to a plus bx, where a and b will be the regression parameters, b will be the regression coefficient. Likewise, if x is dependent on y, beta, the equation to be formed will be x equals a plus by. Again, a and b, beta, are your regression parameters. B is the regression coefficient. To compute these regression equations, guys, we follow the method of least squares. Agar y is equal to a plus bx karna hai, beta, what we will do is, one second, we will plot all the values of x and y, guys, on a graph. We will try to fit in an equation, guys, between these points, which is called as a line of best fit. While you introduce this line of best fit, the objective is to ensure that the difference between the value of y as given by this line and the actual value of y is as low as possible. Minimization of, वो difference को बोलते हैं error or residue. Your objective, beta, will be to minimize the errors, summation of errors. We do not directly add errors, instead we square the errors, because few errors can be positive, few errors can be negative. So क्या याद रखना है बेटा यहाँ पे method का नाम, which is method of least squares. You should know that we are trying to minimize the difference between actual value of y and estimated value of y, and for that we minimize vertical distances. So if it is y on x, it is minimization of vertical distances. If it is x on y, guys, we keep y value constant and minimize the difference between actual value of x and the estimated value of x. That is minimization of horizontal distances. This minimization of horizontal distances and vertical distances can result in two different equations. That is why we have y on x equation separately and x on y equation separately. When will you have only one equation? When r equals +1 or -1. When r is +1 or -1, all the plotted points are already lying on a straight line. You do not have to worry about introducing any line of best fit. That line itself, beta, is the regression equation. Because there's no minimization of distances, you're going to get the same equation, beta, for both y on x as well as x on y. Are we understanding this? ये भी याद रखना जरूरी है. So to derive this, beta, you write summation ei square is equal to y minus a plus bx square. I told you, beta, this equation is differentiated once with respect to a, once with respect to b, guys. This is where we form two normal equations. Normal equations, नाम याद रखना है तुम लोग को. Method of least squares, minimization of vertical distances, minimization of horizontal distances, normal equations. Normal equations, beta, summation x, summation y is equal to na plus b summation x xi yi is equal to a into summation x plus b summation x square. Plus b summation x square. This will be the two normal equations, guys. By solving these two normal equations, we are going to get byx and bxy. Byx as such, guys, will be equal to covariance between x and y divided by variance of x, which can also be written as r into standard deviation of y by standard deviation of x. Yaad rakhna, if it is y on x, x is always in the denominator. And then the last formula, beta, will n summation xi yi minus summation x summation y by n summation x square minus summation x whole square. Same way, beta, with bxy. Once you compute byx, you will have to substitute x bar, y bar and byx in y equals a plus bx in order to compute the value of a. To be clear, once you get the value of a, you have the regression equation, y is equal to a plus bx. The most important is formulas for regression equation and then the properties of regression equation. The first property, guys, of regression equation, guys, is that r is the geometric mean of byx and bxy, or r is equal to under root byx into bxy. The point that you should remember here is that if both byx and bxy are positive, r will be positive. If both byx and bxy are negative, r will be both of negative, matlab they have negative slope, they are negatively related. Common mistake students think because both of them are negative, product is positive, and that is why r is positive. दोनों slope negative है, मतलब रिश्ता negative है. That is why r will be negative. One is positive, one is negative, mathematically not possible. Using this also, beta, I said, if they ask us to identify which among the equations is y on x and x on y, you will have to assume any one equation as y on x, the other will become x on y, convert them in the form of y is equal to a plus bx, x equals a plus by, compute byx, bxy, product low. If the product is less than or equal to 1, your assumption is correct. If the product is not less than or equal to 1, it is the other way around. Are we clear, guys? Next property, beta, is that the point of intersection of the two regression equations is x bar and y bar. And if there's only one regression equation given, guys, that means the regression equations as such, guys, coincide. There's only one line. That means r will either be +1 or -1. कैसे identify करोगे +1 है -1 है? b अगर पॉजिटिव है, perfect बेटा, r is positive +1. अगर b नेगेटिव है, r is माइनस. It all depends on the slope. If slope is positive, that means it's an upward moving straight line. That means r is plus 1. Slope negative hai, that means r is minus 1. Regression coefficient being slope of the straight line, guys, obviously will get affected by change of scale. It will not be affected by change of, I said ignore the formulas that are given. All you have to do beta is b, v, u. V and u are two new variables in terms of y and x. So b, v, u will be equal to coefficient of y divided by coefficient of x into b, y, x. Agar b, u, v hai, you will need coefficient of x by coefficient of y into b, x, y. X on y dega, only then they can ask you u on v. Or they will give you y on x and they will ask you to compute v on u. And then beta, if the two regression lines as such guys are perpendicular, then r will be 0. I said do not literally compute slopes and try to multiply, because यहाँ पे beta you will not have y value in terms of x, x value in terms of y. दोनों में रहेगा ही नहीं. That is where the variables will be independent. That's it. Anything? हाँ beta. Then yes guys, we also did about nonsense correlation as such beta, spurious correlation. This arises when two variables are not directly related, but then they're related on account of a third variable. So that is only because of that as such beta, we're trying to get some relation between these two variables, also known as spurious correlation. That's it. All that beta. That's the end of correlation and the end of the class as well. Online students, end of the class.